Okay, we're going to be looking at trying to factor things completely. So, all the way factoring down any type of equation. So, the ones we have today, and we're going to cheat a little bit and look at the flow chart from tomorrow. But when we're looking at it, the first thing we're always looking for is a greatest common factor. Because if I can pull out a 5 or a 3 or a 24 or anything or a 6x squared, then I want to pull that out from all of them first because that's going to make it as easy as possible. Then today we're going to be looking at, might see a few difference of squares, then ones that we can factor using a process or factor mentally, and then the ones that have four terms where we factor by grouping. So that's kind of what we're looking at today on this assignment. So first one, I'm looking for any greatest common factors, and I don't have any factors for this one. So nothing I could divide both of them by. But since there's two terms, it should be a difference of squares, and I could take a square root of both of these. So difference of squares says that I'll take the square root of the first one, should just be 2x, because 2x times 2x would be 4x squared. And then the square root of the second one, which is 5, and I'll write it as term A plus term B, and then term A, 2x, minus term B. And if you check that, multiplying it back together gets us right back to that term. Anything that's in the middle would end up canceling out. For the second one, I'm noticing right away 16 and 4 will both divide by 4, and they both have an x term. So looks to me like we could divide both by 4x. When I do that, the 4x is going to move out front, and then 16 divided by 4 is 4. There's still another x there. And then 4x divided by 4x gets rid of both of those terms, but we need a 1 to hold the place. Otherwise, it will not multiply back in. So that one, all we can do is factor that out, and we're done. Looking at number 3, for this one, I don't have anything on this one I can divide them by, and so I'm going to use a process. That process we've done is start out by multiplying the A value and C value. So it'd give me negative 18. And then I'm looking for something that multiplies to get negative 18, adds to get negative 7. So as I'm going through my terms, I need a positive and a negative. 6 and 3 doesn't work. So if I do 2 and 9, I believe that's going to work for me. So remember the B value is a negative 7. So a bigger number is going to be negative. Smaller number will be positive. And so my two terms for that start out as x minus 9, x plus 2. But I notice on that x times x does not give me 3x. Negative 9 times 2 doesn't give me negative 6. So my solution for that is to pull out a 3 from one of these. So when I'm looking to pull that out, I can divide 9 by 3. And so when that divides by 3, you could think of it either as saying, well, that divides by 3 and 2 doesn't. And so that 3 would slide up front. Or you could think, I robbed that 3 from the 9 and it moves up here to the x to satisfy all the parts of that. Either way, we're going to end up with x minus 3 and 3x plus 2. That would work out for 3x times x is 3x squared, negative 3 times 2 is negative 6, and everything in the middle subtracts out to what it needs to be. And on the next one, looking again for greatest common factor. So these do have a common factor of 7. So I'm going to have a 7 out front, then x squared plus 4x plus 3. And anytime I've got a larger number in the middle, I'm automatically going to think, like, well, when I'm doing multiplies to get 3, adds to get 4, it should be that number in 1. And so two factors of that would be x plus 3 and x plus 1. All that multiplies back together and multiply by the 7. We get back to those same terms. But again, we're looking for those parts that are factored out. And looking at number 5, I know those will both divide by 2, I think 4 as well, and even 8. So they would divide by 8, but they also all have at least one x. So I can actually divide these by 8x. So when I divide that by 8x, again, I'll put the 8x up front. That gives me x squared. Negative 48. X squared divided by 8x would give me 6x. And 72 is 9 times 8. So that x gets rid of the other x. 72 divided by 8 is 9. And then I've got something that I need to find. What multiplies to get 9 and adds to get negative 6? The only way for that to work is if there are two negatives. So I believe a negative 3 and a negative 3 is what's going to work for me. Negative 3 times negative 3 would give me positive 9, and add together to get a negative 6. So my factors would be x minus 3 and x minus 3, or we could just write it as 8x times x minus 3 squared. Or you could write it out twice. Either way works for you. On the back, looking at 6 and 7, the main differences here are that you've got a y at the back. So I'm just going to look at number 7 because we would do some multiplying here to get 3 times negative 20 to get a negative 60. And then looking for something that multiplies to negative 60 and adds to negative 7. So doing that, I want to say that was 5 and 12. So negative 12, positive 5 would give me that negative 7. And so the terms I start out with are x minus 12 and x plus 5. Again, remember, these two terms don't multiply to give me a 3x. So I'm going to rob 3 from that 12, and it's going to move up there. Or you can think of it as dividing both to slip and slide. Either way, that gives you x minus 4 and 3x plus 5 for my two terms. Oh, wait. So we've got a y there. So the only thing that's different here, my numbers remain the same, but at the back of that, there should be a y because it decreases in reverse the same way that the x decreases as you go forwards. So be x minus 4y and 3x plus 5y, like that. Now we get into the ones that are a little bit new. So when you have 4 terms like this, what we're going to do is split them up into 2 binomials added together. So 24x cubed plus 8x squared, all that plus 12x plus 4. And I'm going to see if I can pull out some common factors. So these would both have an x squared, and they would both divide by 8. And then over here, both those would divide by 4. So that gives me 8x squared. 24 divided by 8 is 3, and then so 3x plus 1. And I'm going to put the plus 4. 12 divided by 4 is 3x plus 1. And so I have these two terms both multiplied by 3x plus 1. So when we do that, we can combine the 3x plus 1s and say they're multiplied by this plus that. So I would write it as 8x squared plus 4 times 3x plus 1. And those would be my two terms. A similar thing for number 9. I'll split them up. I'm going to keep that negative sign with the 5x. And so still keep them as added together, but I'm going to keep that negative there. So I've got an x squared that I can take from both of those. And it looks like 6 will divide by both of them over here. And both of these, I'm just going to pull out the negative, so negative 1. So if I do 6x squared, 30 divided by 6 gives me 5, so 5x, and plus 3. Then I put that negative 1, and that changes that to 5x plus 3. So again, I've got the same thing. So I'll rewrite it as 6x squared minus 1, all that times 5x plus 3. And so when you look at it, if you multiply all that back together, you do get back to this original 4-term product there. And the last one, we're doing the same thing, splitting them up, keep the negative there, make that a positive. I would have x squared, and then that would divide by negative 9 to give me x squared times 2x plus 1, and then a negative 9 times 2x plus 1. All that to give me, those two to combine to give me x squared minus 9, then 2x plus 1. So that's taking, and again, looking at our chart to finish it up, we've done checking for greatest common factor, which I probably forgot to do on one of those. Then we had a couple difference of squares, used the process or factored mentally, and then at the end, those last 3, we did grouping. So that takes care of that for us, and good luck with it.